In this video, I'm going to go over how you can utilize the native JSON-rpc API that is available in almost every core wallet. One of the features a lot of people don't realize, especially if you're new to crypto, is that core wallets all have a RPC exposed to them, which was initially introduced with Bitcoin. It allows you to interact with the wallets through any type of API. So you can create a Python script, you can create a .NET application, you can create pretty much anything you want, as long as it has the capability to do a HTTP post. You're able to call these APIs and pretty much interact with the wallet as much as you want. You can do it remotely, you can do it, on the same system, whatever you want. Some common use cases for this might be if you're running a Masternode, such as I am over here. If this ever goes to missing or anything like that, then you can actually have it auto start. So as an example right now, this has a Sentinel ping expired, which means I'm not receiving rewards for this. So in this video, we're going to actually create a executable that we can just run on a HiveOS rig in the background that will monitor for this and auto start it if it ever goes stopped. In addition, another thing you can do is you can monitor your wallet balances, and for less common masternodes, if you don't feel very strong about the project and you just want to auto trade those rewards, you can certainly do that by auto sending them to an exchange. So we're going to start off. First thing we need to do is we need to enable the RPC server. So to do that, you're just going to go to Tools, Open Wallet Configuration File, and then here we need to put some lines. So we're going to start off with server equals 1. That's going to actually turn it on. Then we need to do RPC port equals, and we need to give it a port. For me, I'm going to use port 9001. Then we need to create a user. We're going to do RPC user equals, I'm just going to call this retro mic. And then we need to give that a count of passwords. We're going to do RPC password equals, and I'm just going to do password. We're going to save this. And there's actually one more line you need. You need RPC allow IP. Now this is an optional line, but if you are using a different computer to connect to your wallet API, you need to specify either the IP of that or the IP of your network, depending on how many systems you kind of want to open this up to. For me, I'm just going to lock it down to one system for now, and that system's going to be 192.168.1.2. Go ahead and save that, close this. We now need to close the wallet and reopen it. So I'm going to close that wallet. Wait for it to shut down. Okay, and then we're going to reopen it. And while that's reopening, what we're going to do is we're going to hop on over to Visual Studio, and we're going to create a new project. I'm just going to open Visual Studio, and we're going to create a new project. And I'm going to do C# Linux so that I can run this thing on a HiveOS rig. And we're just going to call it console app is fine. Let's see what our options are here. Yep. Next. And now we need to give it a name. I'm just going to call this thing crypto bot. And that's all we're going to do. Next. .NET 6.0 is the LTS version, so that's good. Go ahead and hit create. It's going to pop you in here, and we're just going to remove everything that's there. First thing we're going to do is we're going to add a NuGet package. And it may seem like I'm going pretty quick with this. This is because I'm extremely familiar with .NET. .NET development has been my career for quite a while. And so I'm very familiar with Visual Studio. You can do this in any platform that you see fit. But for me, I'm going to do it in C# just because that's what I am most familiar with. And it's the quickest and easiest for me. So we're going to do rest sharp. We did not want to install that. We actually want to change the version here. So once this pops up, I'll actually say no. I'm actually going to hit cancel here. And I'm going to change the version to 106.15.0. I like to stick with this version just because it's a little bit easier to do the configuration, especially with credentials. Now we can start building our application code. First thing I'm going to do is I'm going to create a method. And I'm going to call this Zoc wallet. We're going to call that method on launch. And within here, I need to start building out my request client. First thing I'm going to do is I'm going to create a variable for the RPC username, which we called RetroMic. And then our RPC password was capital P SSW0RD. Now we need to create a client. So we're going to do var client equals new REST client. It's going to use the REST sharp library. And then in here, we want to specify our base URL, which in our case is going to be the IP address of the server. And the port that we specified in that config file, which was port 9001. Then we need to create a request. So we're going to do a new REST request. Empty string for the resource. And our method is going to be a post. And now we can create our request object. So to do that, we actually need to import another library. We're going to use JObject. You just type JObject and then do a control dot. Here you can install the Newtonsoft JSON package directly from the code editor. And we're going to call this request data. And within here, we're going to create 3 J properties. So we're going to create, we're going to do add object. And we're going to do a new J property. And then we want to name the first one, we want to be json-rpc. And the value for that is going to be 1.0. You should put those in double quotes. We can go ahead and copy that line. We're going to need 2 more of those. The next line is our ID. This should be unique for every request. So we're just going to use a GUID. We're going to create a new GUID. This will generate a unique ID based on the hardware in our system. And then next, we're going to do method. Oops, in double quotes, you got to do method. And then the method is going to be get balance. Okay. And now we can do, we can cast that to JSON. To do that, we'll do var JSON data equals. We're going to do a JSON convert dot serialize object. And we want to give this thing the request data, which looks like I used the wrong names over here. So these should actually be just add on these. Oops. All right. So now we have all those loaded into our JSON data. That's going to give us the JSON payload representation of our object. Now all we need to do is do request add JSON body. We're going to add that JSON data. And now we can actually execute the method. So we're going to do var response equals client.execute. And we want to pass in the request. This is going to actually call the HTTP web service that is now up and running on that Qt wallet. Then we want to grab the response. To grab the response, we already have response there. I like to do dynamic object here. So I like to do dynamic response data equals response.content. Okay, so that's going to take the response message and put it into a dynamic object that we can essentially dot walk to get whatever data we need. But in the event there's an unauthorized error or anything like that, this line would fail. So first, we're going to do an if statement, and we're going to check to see if that string is not null or empty. And that's going to be response, which response could be null. So let's go ahead and do content there. Now we can move this line up into here. And now we can parse out our balance. I'm going to do total balance equals response content, response data dot, and you're not going to get any IntelliSense here because it's a dynamic object. You need to know what that payload is. So for us, it's going to be result dot value with a capital V. And then we can do a console.writeLine on that total balance. Okay. And let's go ahead and wrap this in a try-catch up here. So that if it fails, it'll just continue running. And we can have it output the error message. So we'll just do console.writeLine ex.message. Now if we go ahead and, one thing we forgot to do here. When we build the request, we also need to put in the credentials. So request.credentials, we're going to do new network credential. And this is where we're going to specify our RPC user and RPC password variables. Okay. Now if we do Control-Shift-B to compile, now we can do debug, start without debugging. And it doesn't have result. So let's go ahead and see what is wrong with our response data. Oh, so we actually forgot a line here. So the response content we don't want to set directly. We want to do JSON convert dot deserialize. So what that'll do is that'll take response.content is going to be a JSON payload. It's going to take that and it's going to pump it into a dynamic object. Okay. Go ahead and build and run that again. And here you can see this is our wallet balance, right? We've got 5,062. And if we hop on over to our wallet, we can see we have 5,062.58. It's a quick, easy way to get your balance. Now that we verified we're able to retrieve our balance, our next step is actually going to be to set a threshold and then auto send that every time the app runs. So to do that, I'm going to go ahead and create a variable that will hold our destination address. I'm just going to do destination address. And we'll plug that in later. And we can remove the write line. And the other thing I'm going to do is I'm going to create a variable here. We can do bar. And we want a variable that can hold basically our locked collateral. And the purpose of this is we want to deduct this so that we never send our locked collateral. So I'm going to do reserved amount. And in my case, our locked collateral is 1,000, but I'm actually going to hold an extra 500 coins in my wallet. So I'm going to say the reserved amount is 1,500. And down here we're going to say if our total balance is greater than or equal to, if our total balance minus our reserved amount is greater than or equal to, and I'm just going to pick a threshold of 25. Basically what this says is if our total balance, which is currently over 5,000, minus our reserved amount, which is 1,500, exceeds more than 25, then we want to send the tokens to the exchange or to whatever destination wallet you may want to send it to. So to do that, we're just going to create a new request again. And similar to above, the resource is going to be an empty string and the method is going to be a post. Right? And then we want to set the credentials as well. So we can just go ahead and copy that same value again. And same thing with the header. Which we actually didn't set before. So one of the things, this is generally optional, but one of the things I like to do is explicitly specify a request header. And this is to specify the content type. So it's going to be content-type, and it needs to be application/JSON-RPC. In normal JSON web services, it's usually application/JSON. But for this RPC to work, it needs to be JSON/RPC. We'll go ahead and plug that in down here as well. And then we're basically going to create another request object. I'm actually just going to copy this whole thing and we're going to adjust this. We can just reuse request data. And for this, we still want the 1.0, we still want the GUID. But our request is actually going to take parameters, and it's going to take an array. So to do that, we want to create a JArray, and we're going to just call this request params. And we're going to create just an empty array object, and then within request params, we need to add a few things. We need to add the destination address, followed by the balance that we want to send. There's no corresponding names to these. So what you want to do is you just want to use the values. In this case, it's going to be destination address. And I'm actually going to adjust this calculation to be var balance to send. And we're going to plug this in there. And we'll use balance to send here. And this way we can reuse that value. So now we can use, now we can do request params.add, we can paste in balance to send. So now we have those, and now we want to set the method of this is going to be send to address. And then we need to add another property. Oops, not a header. Add new J property. And this is going to be called params. And this time, instead of a string value, we're going to use our request params object. Alright, now we can clean up this code a little bit. And we can build the JSON now that will become the request body. So let's just do our request. We can actually probably reuse what we had before, which was just the JSON data. Right, so we're going to serialize this request data object into this JSON data string variable. And then we just need to add that to the body. just like we did up here. So we're just going to copy this. We can reuse those objects. And now all we need to do is just call the post. So it would be client.execute, pass in the request, and this should post it, and this should send that balance out to the exchange. So the only other thing I need to do here is I'm going to need to plug in a wallet address. So let me do that real quick. Alright, I've got a wallet address. We're going to go ahead and plug that in there. And I'm going to put a breakpoint right here, just so that we can watch that thing execute. Okay, and here we can see, if we look at our body, we're going to be sending it to this address, and that's going to be the amount it sends. Right, which is basically that 5,062 we have minus 1,500 we want reserved. Go ahead and hit F10, let that execute. And here we can see status is okay. Now if we jump over to our wallet, here we can see that transaction got sent out. So minus 562.58. We actually have 1,499.99 because of the transaction fee that accompanied that. It dropped it down a little bit to like 0.001. Not a big deal. Now, anytime we run this on an ongoing basis, it's going to maintain this around 1,500 ZOC in our wallet, send anything else to the exchange. I'm already running my RetroMic mining tools that is auto-exchanging that for Bitcoin. Now, the other part to this I mentioned earlier is that sometimes this node may not be fully up and running. Here we can see mine is up and running. It corrected itself. However, sometimes that may not happen. And so I'm going to show you how we can set it up to auto start if it ever gets detected that it's down. So let's jump back on over to Visual Studio. And what I like to do is I like to create another method for this called Masternode. And we'll basically just call this and within here it's going to be very similar to this. So we're going to need our RPC username password, we're going to need the client, we're going to need a request, we're going to need our credentials, we're still going to need the header, we're still going to need a request object and request data, and we're still going to want to call the response. I can go ahead and paste all this in here, and we can reuse some of this logic. Essentially, all that we're looking to do here is we want to call the Masternode command and pass in an argument. So it's going to be kind of similar to what we did down here with the additional params. So I am going to copy this part as well. And we'll replace this with that. And now what our params are going to be is simply a command. So for this one, the method is going to be Masternode, I believe. If we're unsure of what that command should be, we can always hop over to the wallet, go Tools, Debug Console. We can type Masternode, and here we can see Masternode. I can just hit Enter here, and this is going to give me a list of commands. And what we're looking for here is we're going to be running Masternode start missing. So essentially we're going to reproduce the logic that would be ran if we did Masternode start missing. And here you can see it didn't start any because they're all currently running, but this is the command that we're looking to run. So let's go ahead and set that up. So we've got Masternode here. Our params, we can actually simplify this a little bit by doing, since we only have one param here, I'm just going to do params, and I'm going to do a new J array. And within this, you can see we can just specify what we want in here. So to do that, I'm just going to do start missing. And that should be all that we need to do. Can actually remove those. And so if we just take a look at this, we're going to be calling the same endpoint. We are going to authenticate with our same credentials. We've got our version, we've got our ID, we've got a method of Masternode, we have a param of start-missing, and that should be all that we need. So now, if we put a breakpoint here, and we go ahead and run this, hit F10, step through these, we take a look at the JSON data. We can say we're going to be passing in Masternode and then start missing. And if we look at our response, we have an OK message. And if we look at the content, it's the same as if I ran it from that debug console. So everything is good now. So now under any circumstance that it stops, this will allow me to restart it. And all I need to do is set this app up as a scheduled task. You can do this in HiveOS. You can do this on a Windows machine. Basically any machine that you have up, you could just set this thing to run every hour, and it will continually monitor my wallet balances, and it'll monitor the Masternode and make sure it's up, and then it will also auto send those funds to the exchange, and then my other tool will pick those up, auto exchange them for whatever currency I want, and I also have auto withdrawal set up, and so that will auto withdraw to my hardware ledger once the balance threshold is met. That's it for this video. Just kind of wanted to walk you guys through how you can leverage the APIs that are available under pretty much any fork of Bitcoin, or pretty much anything that uses a Qt wallet. And it's very basic, doesn't require much effort. You just need to know a little bit of coding. In the end, all it's doing is HTTP post requests, and then for the balance, we're interpreting the results and running some calculations to determine what we're sending out. You can do this in Python, you can do this in Ruby. I did it in .NET. You can download Visual Studio Community Edition for free, and you can basically replicate my code, replicate the process of this video, and that'll have you up and running in no time.